Hi students, now I will talk about velocity versus time graph, and we need to understand what is the acceleration. Okay, starting using this graph, I need to ask, I talked before that in mathematics we have the x coordinate and the y coordinate, and we have a point which is xy. But in physics we have, until now, we know that t at the x-axis and the position or x at the y-axis. In this example, we have the velocity at the y-axis and the time at the x-axis. So the x-axis carry the time in seconds, and the y-axis carry the velocity, not the position as the previous example, which is in meters per second. Now, simply I need to assign these points in this graph. I need to put each point at its position. Okay, at t equals 0, I have the velocity is 0. At t equal 1, the velocity is 1.5. This is 1, 2, this is 1.5. At t equal 2, the velocity is 3. At t equal 3, 4.5. Okay, this is 4.5. At t equal 4, I have the velocity is 6 meters per second. And at 5, it is 7.5. Okay, this is the point representation in this graph. Now, if it is required, I can draw a line. This straight line if we get back to mathematics, I have the equation of the straight line is y is equal to ax plus b. I should know that a is the slope and b is the y-interception, and x is x, y is y. How can I calculate a? A, which is the slope, is y2 minus y1 over x2 minus x1. This is the slope. The slope in the previous example was the velocity. We can see that the slope was the velocity, which is delta x over delta t in the previous example. But now we don't have the position at y-axis, we have the velocity. So what if I need to compute the slope? If I need to find the slope in this graph, so slope is equal to delta v over delta t, which is v2 minus v1 over t2 minus t1, which is the same as v final minus v initial over t final minus final t initial. The rate of change in velocity during a period of time is the acceleration. So I can calculate the slope for this line. The slope will be, I can pick any 2 points to calculate the slope. I can take this and this, which are the same from the table. So I can take this, which is t final and v final, and this is t initial and V initial. Okay, T final is 4 seconds and V final is 6 meters per second. T initial is 2 seconds and V final is 3 meters per second. Now I can find the slope. V final 6 minus 3 divided by 4 minus 2, which is equal to 3 over 2, which is 1.5. What is the unit? Get back to the unit. The units for the velocity is meters per seconds. The units for the time is seconds. So I have it meters per seconds per seconds. In this case, it will be meters per second multiplied by 1 over second. It will be meters per squared second. So the unit of the acceleration is meter per second squared, but the units for velocity is meter per second. Is that clear? Okay, I'll move to the next example. Okay, what I represent in x and y. In x it is the time and y it is the velocity, v in meters per second, and at x-axis it is the time in seconds. Okay, now I have this graph for a moving body. I have positive slope, zero slope, negative slope. For velocity, the slope is the acceleration, and here also the slope is the acceleration, and also here the slope is the acceleration. The slope is positive, so I had positive acceleration here from 0 to 5 seconds, and we have 0 slope from 5 to 10. We can compute them. Also we have negative slope from 10 to 12 and a half. So we have positive acceleration, zero acceleration, negative acceleration, we can call it deceleration. Okay, we need to fill the table. How can we read the information from a graph? At t equals 0, what is the velocity? At t equals 0, the velocity is 0. I don't need to put meters per second because they are put in the title row. Okay, at velocity equal to 1 meter per second. How? At what time the velocity is 1? This is 1 and this is the time. I come from the y-axis, which is the velocity, and get back to the x-axis, which is the time. The time was 1 second. How much the velocity at t equals 6? This is t equals 6. How much the velocity? How fast the body is? It is 5 meters per second. At t equal, what is the time when the body has the velocity 3 meters per second? This is the time. Okay, it is 3 seconds. But wait, we have at B and at D different thing. At velocity 1 meter per second, I find that the time is just 1 second, but I have another point that the velocity was 1 meters per second, which was at 12. So I have 2 times. Also at 3 meters per second, I have another time the body have that speed at t equal 11. So the body has the same velocity twice. Okay. The first when the body is accelerate. The second when the body is decelerate. Now at t equal 12 and a half, the speed or the velocity of that body is 0. It is stationary. When the velocity is 0, then the body is stationary. When the velocity doesn't change, like from 5 seconds to 10 seconds, that means the acceleration is 0. So the body at this in this period has uniform motion or velocity because the acceleration is 0. Okay. What if we need to compute the acceleration from 0 to 5? The acceleration from 0 to 5 is the same from 0 to 1 or from 0 to 2 or from 0 to 3 because we have a constant acceleration, a constant slope. We have a straight line, so we have a constant slope. Also, if we need to take the instantaneous acceleration at a point, the slope is the same for all the line and for each point. So the instantaneous acceleration and the average velocity acceleration is the same. So the average acceleration is equal to v2 minus v1 over t2 minus t1. I can pick any 2 points lying on the line. So v2, I can take this and this, or this and this. I'll take this. v2 is 5 minus 0 divided by 5 t2 at this point. t1 is 0, which is 5 over 5, which is equal to 1 meters per squared second, which is positive. That means the body is increasing its velocity. The velocity is increasing. What if I have negative acceleration? Okay, in this period, I will take these 2 points. Acceleration from 10 to 12, for example, 12 and a half. The third period is equal to v2. I will take this, and v2 is equal to 1. I'll use this color. Minus v1, which is 3, divided by the difference in time, which is 12 minus 11, which is equal to 1. 1 minus 3 is minus 2 over 1, which is minus 2 meters per square second. This means that the body is decelerate. Okay, the acceleration is in negative sign. That means the velocity of the body is reduced. The acceleration here, we can compute the slope. We can find it is 0. So the acceleration is 0. Okay. Now we need to use the same graph to find the acceleration, average acceleration between different points, and the instantaneous acceleration. We will find it in another graph. So find the acceleration during these points. You can do that. What is the unit of the acceleration? We find it. We found it. It is meter per square second. Be careful for that. If the acceleration is positive or negative, what is the mean of that? If it is positive, then the velocity is increasing. If it is negative, the velocity is decreasing. Here is acceleration, we can call it. Here also we can call it deceleration. but in both cases it is acceleration, positive or negative. I think you can do that by yourself. It is easy. See you in the next example.